In this video, we're going to talk about some mathematical models, or they call it building functions. Okay, so what we're going to do is create a function that illustrates a concept or a particular scenario. Okay, so there's going to be a couple of different scenarios, and we're going to try and make a function to solve the problem. So let's start with number 1 here. So if P is any point x, y on the curve y equals x squared minus 1, we want the distance from P to the origin. And we want to express it as a function of only x. Okay, so I want the distance in terms of x. So sometimes it helps to create a picture. Okay, so what does this look like? So we have our axes. Okay, now we know what x squared minus 1 looks like. So it's the graph of y equals x squared, but shifted down by 1. Okay, so it looks like something like this. So it's a parabola that's been shifted down by 1. Okay, and then we're going to take any point on that line. So let's say that our point is here. Okay, so this is going to be P, which has coordinates x, y. And we want the distance from P to the origin. So that's the middle here. So this is what we're looking for, D. And that point could be anywhere on this parabola. Okay, so that's what our picture looks like. So what does it mean for P to be on the parabola? So P equals xy on the curve means that x and y satisfy the equation. Okay, so that means that y is equal to x squared minus 1. In order for them to be on that curve, this needs to be true. The y value has to be the x value squared minus 1. So we know the coordinates of P, and we know the coordinates of D, or not D, sorry, the origin. So the distance, we have a formula for the distance between 2 points. Maybe I'll just write that. So what we want, distance, actually let's write D equals, okay, the distance between, I'm going to call it O, okay, for the origin, so 0, 0, and P, which is xy. So the formula for D means that this is going to be the square root of x minus 0 all squared plus y minus 0 all squared. Okay, so that's just using the distance formula. Now, since we know y in terms, because we want D in terms of only x. Okay, so right now, so here we have D in terms, in terms of both x and y. Okay, so we want to get rid of the y. Okay, so let's just simplify this. This is just x squared plus y squared. Okay. So now, because we know what y is in terms of x, we can replace the y. Okay, so y we know is x squared minus 1. Okay, so because we know this, we can replace the y here with x squared minus 1 because they're equivalent. And now I have D in terms of only x, but I mean we could expand this if we want. So this is x squared plus x to the 4, minus 2x squared plus 1. So that means that D is going to be the square root of x to the 4 minus x squared plus 1. And that is in terms of only x. Okay, so this gives the distance in terms of only x, which is what we were looking for here. Okay, let's try another one. So we have a rectangle in one corner of quadrant 1. Now, in case you're not familiar, so let's just go up here. The quadrants they're talking about, so this is the xy plane. Okay, this is quadrant 1, and then it goes counterclockwise. So 2 is up here, 3 is down here, and 4 is down here. Okay, so quadrant 1 means that we're in this quadrant here, where both x and y are positive. Okay, so a rectangle has one corner in quadrant 1 on the graph of 9 minus x squared, another at the origin, a third on the positive x-axis, and a fourth on the positive y-axis. So we want the area of the rectangle as a function of x. So again, a picture here might be nice. So let's draw that. Okay, so we're only in quadrant 1, so we can draw this kind of low. Okay, so there's x and y. Okay, so now what does this graph look like up here? So the negative, actually maybe I should just rewrite this. Okay, so this is actually y equals negative x squared plus 9. So it's been flipped over the x-axis because of the negative sign. So it was like this, okay, and then it was shifted up by 9. So that means it's going to be, the vertex is going to be at 0, 9, okay, and then it's opened down. And the x-intercepts are actually going to be at negative 3 and positive 3. Okay, so this is what our parabola looks like. Okay, so now we have the rectangle. Okay, so we're drawing a rectangle. So it has one corner at the origin. Okay, one of the corners in quadrant 1 on the graph somewhere. So let's say it's here. Okay, so this is going to be a point xy. Okay, and then it's going to have its other point related to that point. Okay, so there's our rectangle. Okay, so that's the rectangle we're talking about. Okay, so the origin obviously has coordinates 0, 0. Now we can talk about these points, the coordinates, in reference to the point xy. So notice that the one that's down here has the same x-coordinate, but it's on the x-axis, so the y-coordinate is 0. So this one has coordinates x0. And similarly, this one has the same y value, but because it's on the y-axis, the x is 0, so it's going to have coordinates 0, y. Okay, so that's our rectangle. And then, let me just get a different color here. Okay, so the area for a rectangle is always the length times the width. Okay, so we want the length and the width of this rectangle. So that means we want this length and also that length. Okay, now because this point up here is at 0, y, it means that it's y away from this point. Okay, so this length is going to have length y. Similarly, this length up here is the same as this length down here, and it goes from x equals 0 to x. Okay, so that means it's going to have length x. Okay, so the length and the width are x and y, so that means that my area is actually going to be x times y. Okay, so we think that we're done, except that it wants it as a function of only x. Okay, so we want to get rid of this y somehow. So again, we want to remember since the point xy is on y equals 9 minus x squared, it must satisfy the equation. Okay, so that means y should equal 9 minus x squared. So that means we can replace y here. So I'm going to have a is equal to x times 9 minus x squared. Okay, so that means that my area in terms of only x is going to be 9x minus x cubed. Okay, so that's my area in terms of only x. Now, what is the domain here that makes sense? So we're talking about x values. Okay, so look at where our point x0 is. Okay, so could it be out here? Could I have x equals 4? Okay, well, not really, because my point, the corner has to be on here, and then I would have not a rectangle, right? It's a trapezoid. So I can't really do that. So that means that the biggest x can be is 3. Okay, so x is between, okay, so the biggest it can be is 3. And the smallest it could be, because I'm in the quadrant 1, it tells me, I don't want to have my x over here because then I get a rectangle in quadrant 2. Okay, so that means the smallest it could be is 0, right? It could be here, and I would have a really skinny rectangle. That would be fine. So x is stuck between 0 and 3. Now, do we want to include 0 and 3 is another question. You can. I think they're not really rectangles, but we could include them. They wouldn't really, what I mean is they not being rectangles is if it was here, then my height, so this point is actually the same. It actually is also here. So I don't have any height to my rectangle. It's just a flat line. But let's include them so that part C makes sense. Okay, so I'm just going to make a note here. X equals 0 and x equals 3 don't really make rectangles. Okay, but we're going to see that in part C when it asks for the area. Okay, so the area when x equals 0, I mean, you could just plug into the formula. So it's going to be 9 times 0 minus 0 cubed. Okay, so it's just 0. Okay, now why does it make sense that it's 0? When x equals 0, y is going to be 9 minus 0 squared. So y is going to be 9. So that means, so when x is 0, if we're in the picture, y is going to be 9. We actually just get this straight line. Okay, so that means that there's no width to the rectangle. Maybe I'll write that. So that means that the height is 9, but the width is 0. So it's going to be 9 times 0, which is 0. Okay, now x equals 1. That's going to give an area of 9 times 1 minus 1 cubed. So 9 minus 1, that's going to give an area of 8. And when x is 2, the area is going to be 9 times 2 minus 2 cubed. So that's 18 minus 8, which is 10. Okay, so those are a few different areas. So now that we have a formula for the area in terms of x, you can compute the area of any of these rectangles as long as your x is between 0 and 3. Okay, because it doesn't really make sense after. You wouldn't want to get a negative area. Okay, that never makes sense. So that's that example. Now there's one more. I'm going to leave it for you to try. Okay, so try and make a picture. This one is a circle, but it's very similar to the one we just did, using a circle. Okay, so try to make the picture, and then from that picture, try to figure out what the lengths of the sides are that you need. So this is how we can build functions to solve a given scenario.